Hello, this video is part 2 of task 6.5. I'm going to finish off with the Ferris wheel. So the points at the top, which are the ones that I'm pointing out with the arrows, those mean that you are all the way to the right of the Ferris wheel. Since we're measuring the distance on the ground, that just means that you are furthest to the right on the wheel. Similarly, the points at the bottom would signify that you are all the way to the left. Now moving on to part 2, we are trying to calculate how far to the right or to the left we are at any given time. Previously, it's denoted on the top right, we determined the height at any point. We use sine because we wanted to get the y value being this side right here that I'm circling in purple, and because the y value would be opposite over hypotenuse, we use sine. Now we are trying to find the horizontal distance, which is labeled in blue with the x. I was able to extract this triangle from the wheel, and it's on the right hand side in blue. We are trying to find x, therefore we use cosine of 36, which is equal to x over 25. Put a 1 under the cosine 36, cross multiply, and we get that x is equal to 25 times cosine of 36. And this formula would allow us to find how far to the right or to the left from the center we are located at any given time. I'm going to start with the numbers on the table. So on the right hand side, on the left hand side, it tells us how much time has passed. In the middle, we'll show the calculations. And then on the far right, we'll put the actual position. I started us off at 1 second right here. So this information is for 1 second. From previous sections, we learned that W is 18 and T is 1. So the 18 times 1 would be the angle. We use the formula that we obtained above, which is 25 times cosine of 18 times 1 in order to get how far to the right we are. We'll write that down in the calculations as well. 25 times cosine of 18 times 1. In the previous task, we were adding a number to it because we were finding the distance up and down vertically. In this case, we always start from the center, which is at 0. Therefore, we don't have to add anything in addition to what we're getting. Next, we will multiply 25 times cosine of 18, and that tells us that x is 23.776 feet. In this case, we're going to use 3 numbers to the right of the decimal. So the horizontal position of the rider from the center is 23.776 feet. This means that we are moving from here 23.776 to get to this part right there. Repeat the process at 2 seconds. Now theta is W times T. Again, W is 18. Time is 2, so it would be 18 times 2. We get x equals 25 times cosine of 18 times 2, which is equal to 20.225 feet. Let me write that down and then explain. So you might wonder, well, how come the more time, the smaller the number that we get for our answer? Well, you have to look at what is happening at the Ferris wheel. We start at point A, which is all the way to the right. That would be at time 0. As we move counterclockwise this way, we get to, in 1 second, we would be on this second circle that I'm drawing, which means we are moving to the left. Therefore, we get the 23.776. In one more second, we will be at point B, which is further to the left. That's why we get the purple number 20.225. The number will continue to decrease until we get to here, which would be 0. And as we continue this way, we will get into the negative numbers, because remember, f right here would be negative 25. So from 0 to negative 25, we would have negative numbers. Then as we continue counterclockwise, we'll move from negative 25 closer to 0, past 0, and then when we're back at point A, we would once again have 25 feet.